we just need to tidy up solution equilibria. The last equilibrium constant that you're required to be able to use is Ksp, which is called the solubility product. Now, the solubility product is the equilibrium constant for the dissolving of a solid. So when an ionic substance dissolves, so let's take, for example, barium sulfate. Now, you should know that barium sulfate is highly insoluble. So when we put it in water, the solid barium sulfate will dissolve to form sulfate, barium ions plus sulfate ions. So this is the way in which we write the equation. So it's not the formation of a precipitate from soluble ions, it's the dissolving of an ionic solid. So Ksp is specifically the equilibrium constant for when an ionic substance dissolves. So K in this case is going to be equal to the product of Ba2 plus times SO4 2 minus. Because they're in a 1-to-1 ratio, there's no indices. Now, the product of the concentration of the two ions is called the ionic product. So the ionic product is equal to Ba2 plus times SO4 2 minus. What's the difference between these two? So this is for a saturated solution. In other words, we've allowed the system to come to equilibrium, so as much of the barium sulfate has dissolved as is possible. All right? So how do we know if a solution is concentrated or is saturated or not? So for a saturated solution, Ksp, the ionic product is equal to Ksp. So Ksp gives us the maximum amount of ions of this particular substance that can exist in the solution. So you can't get any more ions in the solution. And so when we reach that point, we say the solution is saturated. So in last year's HSC, there was a question about this. It says, determine the solubility of copper 2 hydroxide at 25 degrees and state the concentration of copper and hydroxide ions. So this was question 25 of last year's trial. It was worth 3 marks. Determine the solubility of copper hydroxide. So this is the first thing that you can do with Ksp. So if we have copper hydroxide, when it dissolves, it will form Cu2 plus ions plus 2 OH minus ions. Now, when you look up the data table, it will have a table of common Ksps. So you turn to your data sheet and it will tell you that the Ksp is equal to 2.2 times 10 to the minus 20. Now, what does this number tell us? Right, so this actual number, what's it telling us? It's telling us that copper hydroxide is incredibly insoluble. Because remember that K is products over reactants. So if the number is minus 20, that means that you've got a 1 on the top, and then you've got a 1 with 20 zeros after it on the bottom. Right, so you get one of these for every 10 to the 20 of these. So there's hardly any ions in solution for copper hydroxide. So this is very insoluble. But solubility is not expressed in terms of Ksp, it's expressed in terms of moles per litre. How many moles of copper hydroxide will dissolve in 1 litre of water? So in order to do that, we have S moles of this dissolve. How many moles of copper will they produce? It's going to produce S moles of copper, and it's going to produce 2S moles of hydroxide. So we're trying to find out what S is equal to. That's what we're trying to find. Now we know that the ionic product, Cu2 plus times OH minus squared, is equal to 2.2 times 10 to the minus 20, because in a saturated solution, the ionic product, this thing, is equal to the Ksp. So at equilibrium, the amount of this stuff that dissolves, we can substitute these in here. We've got S moles times 2S squared is equal to 2.2 times 10 to the minus 20. So now we have 4S cubed is equal to 2.2 times 10 to the minus 20. So S cubed is equal to 2.2 over 4 times 10 to the minus 20. And so S is equal to 2.2 over 4 times 10 to the minus 20 cube root. And when we do that, we get a value of 1.77 times 10 to the minus 7. All right, now have we answered the question? What did the question ask us to do? The question asked us to find the concentration of the two ions. All right, so remember when we're answering questions, we have to go back and check after we finished our calculation that we put down what the question asks for. So the question says, state the concentration of copper and hydroxide ions. So copper ions is equal to S. So the copper ion is going to be okay. We had our break. Let's see if we can focus now. Any questions about that? Now, the other question that you could be asked is, that question was worth 3 marks. All right, so you would have got 1 mark for doing this bit. And then you probably would have got 1 mark for working out S, and then 1 mark for doing this bit. Okay? Now, the other bit about KSP is what happens to solubility if you already have one of the ions dissolved in the solution. So if 1.77 times 10 to the minus 7 moles of copper hydroxide dissolve in water, how much would dissolve in all right, so if we put 0.1 molar sodium hydroxide, will the copper hydroxide be more soluble or less soluble? Right, now the common ion effect says that when we have one of the ions already present, the solubility of the ionic substance will be decreased, will be reduced. But we have to be able to work that out. So here we have same thing. Let's get rid of this over here.
How does that melt it?
Now, in this case, what's the tricky bit? So initially, S moles of this dissolves, but we're starting out with 0.1 moles per litre of the hydroxide. That's already there. So this might be 0, and this is 0, but we've got 0.1 moles per litre of hydroxide. All right, so if S moles dissolves, we will get S moles of this. How much of this will we have? We will have 0.1 plus 2S. So now our ionic product becomes Cu2 plus times OH minus squared equals KSP. So let's just put the number in, 2.2 times 10 to the minus 20 was the number. So when we substitute this in, we have S times 0.1 plus S. Now look at this number here. Does a lot of copper hydroxide dissolve or a little bit dissolve? So since KSP is 10 to the minus 20, would we expect there to be a lot of the substance dissolving or only a little bit? A very small amount. So we can solve this as a quadratic equation, right? It's possible to do that, and if you want to be technically correct, then that's what you need to do. But this is not advanced mathematics, this is chemistry. So we're not interested in whether you can do quadratic equations, we're interested in whether you understand the chemical principles. So we can say since Ksp is very small, S will be small. Oh, I forgot to write it there. Okay, so we could multiply this out and we've got a complicated cubic equation to figure out, and my maths is a little bit rusty. So we're going to simplify our calculation by saying that because S is small, then 0.1 plus 2S is going to be approximately equal to 0.1. In other words, the S is such a small number that it's not really going to make any difference to the effective concentration of hydroxide. So that simplifies our equation here to S times 0.1 squared equals 2.2 times 10 to the minus 20. So 0.01 S is equal to 2.2 times 10 to the minus 20. So that means we multiply both sides by, sorry, we divide both sides by 0.01. So S is equal to 2.2 times 10 to the minus 20 divided by 0.01. Okay, we got it? So compare the concentration of the solubility in pure water compared to the solubility in 0.1 molar sodium hydroxide. There's a dramatic decrease in the solubility of copper hydroxide in the presence of a common ion. Okay, any questions about that?